This video is on the objective calculate a margin of error given a confidence interval, and it is the second video I'm doing on a question related to this objective from your Newton Alta homework. So again, if you're unfamiliar with the topic, try clicking on More Instruction and read what they have to say about it, watch videos, take notes, and then get to their questions, read their examples, get to their questions. And this one's a pretty simple one, and I've already done one like this. I think this might just be the last one I do on this one because they're all pretty similar, all these questions on this objective. So a random sample of college students were asked whether they study more than 4 hours per week in the library. The resulting confidence interval for the proportion of college students who study more than 4 hours in the library is 0.45 to 0.79. Right? So remember what a confidence interval is. A confidence interval is a range of guesses about the population proportion, right? So what they're saying is we're reasonably confident with whatever percentage confidence. Again, usually there's a confidence level associated with a confidence interval. You know, I'm 95% confident, 90% confident, etc. So we're saying here we're reasonably confident that the proportion of all college students, right, the entire population that study for more than 4 hours in the library is somewhere between 45% and 79%. All right, so we're asked for, what is the margin of error in this confidence interval estimate of the population proportion? So in order to answer this question, again, you need to remember how a confidence interval is formed. So I'll refresh your memory here. So a confidence interval is formed in the following fashion. Now, in the middle here, you could have P. Here we're talking about population proportion this time. Again, sometimes you might be talking about the population mean, so you might see mu in here. You're making a guess as to what P or mu are. And there is a lower bound and an upper bound for these confidence intervals. And they're both formed in a similar fashion. You have your point estimate. Now the point estimate is a single value from the sample. So that's either p hat, or if you're talking about means, the sample mean, x bar. And then minus the margin of error, which I'm going to abbreviate ME. That gives me the lower bound. The upper bound of a confidence interval is our point estimate. Again, either p hat or x bar plus the margin of error. All right, so in our particular example, this particular question, they're giving us a confidence interval for p as the lower bound 0.45, upper bound 0.79. And this is for p. So they're saying that we're reasonably confident that the population proportion, the proportion of all students who study more than 4 hours a week in the library, is between 45 and 79%. All right, now there are two ways you could find the margin of error. One is to find the middle. What is p hat? You remember the very middle of the confidence interval is where our point estimate is. So you could find the point estimate, right? The proportion of our sample that we took, the random sample of college students that were asked, whether they spend 4 or more hours studying in the library. We could find that sample proportion by finding the middle. Now the middle is just the average, right? What's exactly halfway between 0.45 plus 0.79, and then divide that by 2. So you add these up, that'd be 110 plus 14, 120, 1.24, 1.24, and then cut this in half, right? So the middle, right, the very middle of the interval, halfway between the lower and upper bound, is 0.62. 0.62. So I got 0.62 in the middle, and then you just have to remember then that this upper bound is going to be 0.62 plus the margin of error, and this lower bound is 0.62 minus the margin of error, right? And then you could use either one of these to find the margin of error. So I'll use the upper bound. We know that 0.79 must be equal to the middle, right? The point estimate, the p hat, 0.62, plus the margin of error. And then I can solve for the margin of error by simply subtracting 0.62. So the margin of error must be, 0.79 minus 0.62, which is 0.17. And check it out, if I take 0.62 and add 0.17, I get 0.79. If I take 0.62 and subtract 0.17, I get 0.45. So that is correct for the margin of error. Now, the alternate way to do this, find the margin of error for a particular confidence interval, is to note that to go from the lower bound to the upper bound, the distance between the lower bound and the upper bound is 2 margins of error, right? Because to get from the lower bound to the middle is 1 margin of error, and then from the middle to the top is another margin of error. So you could calculate the margin of error this way. The margin of error is the upper bound minus the lower bound, and then that distance cut in half. So if we were to take 0.79 and subtract 0.45, right, the upper bound minus the lower bound, that distance, and then cut that in half, we should get 0.17. Well, what's 0.79 minus 0.45? That'd be 0.34, and then cut in half would indeed be 0.17. So two alternate methods there for finding the margin of error, when you're given a confidence interval. So the margin of error 0.17. I enter this, submit, and please read your answer explanations, even if you're correct, just to verify what they've done, make sure it's close to or similar to what you've done. And especially if you're wrong, right? Especially if you're incorrect, read their answer explanations. Make sure you figure out where you went wrong. All right, so that was the second question on this objective. Hopefully it helped when you work on this stuff on your own. And thanks for watching.